So very good morning to everyone tuning in for this Utah STEM webinar entitled Current Trends in Big Data Analytics, IoT and 5G. My name is Gan and I will be the moderator for today's sharing session. The presenter for this interesting topic is my colleague, Dr. Robito Ano. Dr. Ano received her Bachelor's of Engineering degree from Gajah Mada University, Yogyakarta, Indonesia. Masters of Engineering from National University of Singapore and PhD from Chulalongkorn University, Thailand. Her specialization is in telecommunications and network engineering, where she now works on anti-collision algorithm for RFID systems and device-to-device communications for 5G systems. Dr. Anor and myself are currently with the Department of Computer and Communication Technology, Faculty of Information and Communication Technology, University Tengku Abdul Rahman. Our faculty is currently offering 6 undergraduate honors degree programs, which are the Bachelor's of Computer Science, Bachelor's of IT in Communication and Networking, Bachelor's of IT in Computer Engineering, Bachelor's of Information Systems, or IS in short, in Digital Economy Technology, Bachelor's of IS in Information Systems Engineering, and Bachelor's of IS in Business Information Systems. All of these programs are closely relevant to the topic for today's talk. In her presentation, Dr. Anor will introduce the basic concepts of the Internet of Things, Big Data, and 5G communication. She will also present about some current and next generation applications that we should be looking forward in the near future. Before I pass the time to Dr. Anor for her presentation, a gentle reminder to the audience about some house rules. During Dr. Anor's presentation, you are encouraged to pose questions using the chat. Do turn on your video cameras in order for the presenter to better engage with you visually. After the presentation by Dr. Anor, the platform will be open for questions from the audience. During this time, you may also raise your hands to ask your questions directly to Dr. Anor. So without further delay, I shall now invite Dr. Anor for her presentation entitled Current Trends in Big Data Analytics, IoT, and 5G. Dr. Anor?
Okay, thank you, Dr. Khan, for the introduction. So, good morning, everyone. Okay, let me share my screen first. Right. You can see my screen. Can see my screen, Dr. Khan?
Yes.
All right. All right. So, okay. Good morning, everyone. So I hope that later we will get some basic knowledge on these 3 big topics. Okay, big data analytics, IoT, and 5G. Yeah. If we see here, they basically are quite big independent topics, but then they are related with each other. So let's see how this technology will actually will be useful for us. All right. So let's start my presentation. Okay. So I think I just start my presentation now. All right. So okay. Before I start, thank you very much for the opportunity from KLESF for the opportunity given to me for this webinar. And the topic for today is current trends on big data analytics, IoT, and 5G system. Right. So this is the outlines of this webinar. Okay. First, I will go to one by one, what is big data, what is IoT, and then 5G systems. And then in the end, I will try to connect these three topics, how it relate each other. All right, so let's go to this one first, okay? Big data analytics, IoT, and 5G. So in the old era, okay, when just example, when we try to or taxi ride, okay, we go to the road, we try to find the taxi, whether there is a taxi pass by or not, okay? But this time, okay, what we can do, I can say just this application, Grab Taxi or Grab Car. Okay, so using the technology, which is including this big data analytics, IoT, and not limit to 5Gs. Okay, the system, the technology allow us, okay, to order taxi using application. Okay, and then this will actually make our life easier, because we don't need to go to the road walking and then waiting for the time that we don't know. Okay, using this kind of application, we can just see, oh, the driver is coming in 5 minutes, the driver coming is in 2 minutes. We can detect from the application. Okay, so this is just an example of these three technologies. Okay, so then, okay, how is actually these three technology? Okay, I'll go to the big data analytics first. Okay, but before I go to the big data, okay, so big data analytics is actually something process. Okay, but the process itself, okay, the object of the process is big data. So I'll go to big data first. Okay, so what is big data? Okay, big data is basically a very large sets of information, and this is massive amount of data which cannot be stored, processed, and analyzed using traditional tools. Okay, for example, if you have your data, okay, you have your pen drive. Okay, for example, you have assignment, you have you are taking 3 subjects in your semester. Okay, you have like manual, maybe tutorial manual, you have lecture notes and everything. You can organize easily, okay, because the amount of data is just very small. Okay, but if you are talking about data, okay, this must be a big data, must be big. So that's why it's called a big data. Okay, for example, okay, this time I think everybody has a Facebook accounts or maybe other platform social media accounts. Okay, if the user in the world, okay, the population is how many billions now, and then if half of them having the for example, Facebook accounts, okay, Facebook generates about 500 terabytes of data. Okay, data can be the photographs that the account holder posts, yeah, and then maybe the video, okay, maybe the messages, and then maybe just kind of you update your status. Okay, that one is called the data. Okay, but see, okay, how big is the data? Okay, 500 terabyte is quite big. This one is generated every day. But what if every day people keep generating the data? Okay, so the data size is getting bigger and bigger. How will manage that? Okay, so this is we will go to the data analytics later. Okay, so still in the big data. Okay, so if data categorized to be big, okay, the big data characteristic is I have 4 V's here. Okay, actually we can extend to 6 V's, 8 V's, and so on. Okay, but I will go to this 4 V's. Okay, so the characteristic of big data, the first one is the first V is volume. Okay, the volume itself is big. Okay, the how big is it? Okay, not only about I say the 500 terabytes, okay, or 500 terabytes. But okay, if we are talking about other platform or application, for example, you have Netflix, you have YouTube, okay, how many videos are stored, you know, in the clouds, okay, of YouTube or Netflix? Okay, maybe in Netflix there are, for example, 100,000 movies there. Okay, 100,000 movies, and then duration of movies maybe range from 1 hour to 3 hours. Okay, one movies may have about 4 gigabytes or maybe 5 gigabytes. Okay, you can imagine how the size of the Netflix movies that stored in the clouds. All right, so it can goes to maybe about 1 petabytes. Okay, you cannot imagine how many zeros there. Okay, so it's quite big. Okay, and then second is the velocity. Yeah, velocity is this one is speeds. Okay, the speeds of data in this case is not only how the data is generated. For example, you post your you know, you have live Facebook. Okay, you have live Facebook. Okay, the data, how fast you generate this video. Okay, but also you have to consider that how fast is the data processed. Okay, not only how you generate, but also how the data is processed. Okay, because processing is, for example, if we are talking about video processing, how of course when you generate your video, okay, the one that is generated and then later will be sent, okay, through the network will not be as it's not as what you have generated. Okay, there will be a coding there. There is some coding that makes the data to be easier to process. Okay, so it may need compression and so on. Okay, so this process, okay, it should be fast. Okay, otherwise, okay, the user will not get satisfied with the quality of the data. All right, so and then the next one is the variety. Okay, if we are talking about data, okay, compare with, for example, your folder, okay, for your subjects. Okay, you may have maybe slides for your lecture. Maybe you have some Microsoft Word file for your tutorial. Okay, this one is there are not many variation of data, but in big data, okay, the data is vary. Okay, later we will talk about the variation. Okay, the variation of data can be classified in the what they call as structured and unstructured. For example, if you have structure, you have Excel sheets. Okay, of course that one is structured. Okay, you already have some structure there. Okay, but if we are talking about video or image, the one is called the unstructured data, because the video, one video compared with another video is so different. Okay, and then you may also have text also. Okay, so the variety of data is quite big, right? And then last one is a veracity. Well, the veracity is basically how reliable is the data. Okay, whether the data is correct or not, whether the data is consistent or not, incomplete or not. That one is big data. So this one is the 4 V's in big data. Okay, and then as the conclusion for a big data, so big data will contain of different format, okay, of data, as I mentioned, is structured data, for example, Excel sheet, and then semi-structured maybe the email, and then some unstructured is can be a video or pictures. Okay, so you can imagine in the Facebook cloud, or maybe in the Instagram cloud. Okay, there are so many data there. Okay, so many types of data with big size. Okay, so of course this is not easy to store. Okay, not easy to process, also not easy to analyze the data. Okay, so that's why, okay, this come with the data analytics. Okay, so data analytics will perform this kind of storing, processing, and the analyzing. Okay, so for the data analytics, there are traditional approach. Okay, so this one is the traditional approach happen, okay, after a certain period of the time of event. Okay, so this traditional approach, normally they use the traditional tools. Okay, for example, using your Excel sheets. Okay, for example, like you are the owner of the online shop. You may have the list. Okay, what is available items, what is all sold out items. Okay, then how many of item that you want to purchase, okay, and so on. Okay, so it's quite manual, okay, and easy. Okay, but if you are using big data analytics, okay, the analytics should be happen real time. Okay, and in the traditional approach, right, I mean, like you may have like you can do later. Okay, you can do the analytic later, but then in data analytics it must be real time. Okay, so after the data is just generated, so there must be a process there. Okay, so in this case, okay, there is no delay. Okay, there is no delay. Okay, and then I'll go to the next one, which is the big data analytic itself. Okay, so big data analytic is a process to extract meaningful insight from big data stack of raw data such as hidden patterns, unknown correlation, and so on. Okay, so it's just go to the example of talking about business. Okay, so even a small online shop, okay, they must perform kind of data analytics. What is the items, okay, the most wanted items, okay, what is the trend of the buyer, and so on. Okay, so using big data analytics, this kind of trend can be found. Okay, and then the process also include finding the patterns, the trends, relationships between the massive data that can not be discovered using the traditional data. So it's just like when you use Facebook, okay, maybe sometimes you try to search something in Facebook, right? So Facebook will learn, okay, your behavior. What is actually your I mean the Facebook contents that you normally watch and everything. So sometimes, okay, in your Facebook you see some ads there. Okay, this one is actually one example of big data analytics. Okay, so some company, okay, can actually learn, okay, the behavior of the user so that they can perform this kind of advertisement. Okay, and then next we go to the third one, which is the IoT, Internet of Things. Okay, so the Internet of Things, okay, or IoT, refers to the billion of physical devices around the world that are now connected to the internet. Okay, so they can perform data collection, data sharing, and then they are embedded with electronics and internet connectivity. Okay, and also other form of hardware. Normally, it's kind of sensors and everything. Okay, so these devices can communicate and interact with each other over the internet, and they can be remotely monitored and controlled. Okay, so the basic idea of Internet of Things is actually wireless sensor networks. Okay, so how this IoT works? Okay, IoT works actually with these 4 processes. Okay, so the process in the sensors or the device, okay, which is to produce the data and collect the data, and then the connectivity, okay, how the data will be sent, okay, to the cloud, and then how the data is processed, and then the last one is how the data can be viewed or can be enjoyed by the user, okay, using the user interface. Okay, so I'll go one by one here. Okay, so sensor or devices is actually the key component of big data. Sorry, the IoT. Okay, because the sensors and the devices will actually generate the data. Okay, and then they will collect, okay, the data in the IoT environment. Okay, and all this data may have various level of complexities. Okay, it can be like in big data. Okay, but comparing with the big data is that the data collected in IoT is relatively small compared to big data, right? And the data also could be simple. For example, okay, you are using temperature sensor, okay, to monitor the sensor. Okay, so you can collect very small, tiny data there. Okay, or maybe you install a CCTV, okay, in your house. Okay, for this case, since this is video, so the types of data with the big size. Okay, so data is quite vary. Okay, from very small and very big also. Okay, if the second one is the connectivity. So key idea of IoT is connection. Okay, how the devices are connected, are interacted. Okay, so after the data is already collected from the devices, okay, then the data will be sent to the cloud infrastructure. Okay, so the sensors of the devices should be connected to the cloud using various mediums of communication. Okay, so this is the idea. Okay, the communications includes the mobile or satellite networks. Okay, some short-range communication technology, for example, Bluetooth, Wi-Fi, wireless, wide access network. Okay, and then also can be cellular networks. Okay, so this cellular network can be 3G, can be LTE, can be 5G that we will talk later. Okay, so without connectivity, IoT doesn't work. Okay, so then the next one is data processing. Okay, once the data is already in the clouds. Okay, so how this data will be processed? Okay, what for is the data? Okay, so it depends on the application. Okay, so in this stage, okay, the data will be processed. Okay, and yeah, since the data is vary, so sometimes the processing is quite simple. Okay, for example, just temperature is very small, tiny data. It can be complex. For example, using computer vision on video. For example, you want somebody capturing what they call maybe is a vegetable in the farm. Okay, they want to analyze what is actually the problem in the farm, okay, in the particular vegetable. So it needs a very complex, okay, process to do that. Okay, so okay, and then what is the relation between IoT and big data here in the processing? Okay, so actually, if we are talking about these two, okay, they are related, but in this case, the IoT is actually the source of the source data for big data. Okay, so I can say here is many series of creeks and the river. Okay, so here actually the IoT is part of big data, is the source of the data itself. Okay, so once the data is collected, okay, in IoT in the cloud, so then the process itself, okay, will grow to the big data processing or big data analytics. All right, and then the last one of the components of IoT is user interface. Okay, so this is how the information can be retrieved by the user. Okay, so what should the data be available for the users? Okay, for example, okay, just for example, okay, I use IoT to monitor the sea level, the water level in the river. Okay, this one is for flood monitoring. Okay, for flood monitoring. So, for example, okay, if the level of the water in the river is quite high, okay, I can just set alarm, okay, for the users, okay, or maybe some notification for the users, so that's okay. They must be ready if flood come soon. Okay, so this kind of notification is the user interface. Okay, what you want to give to the user. Okay, so in this case, okay, if this data want to come out to the user interface, it must some application needs to be fast also. Okay, so in this example also, when someone, okay, install a camera in the house, but suddenly a thief coming. Okay, so what should the system will give notification to the user? That one is the called the user interface, right? But how fast the user can get the notification is depending on the data processing, also the connectivity. All right. Okay, so I think now we go to the next one. Is the IoT application. Okay, so IoT can be applied in this kind of environments called the smart thermostat. Okay, or maybe connected cars. Okay, so cars can connect with each other. Activity trackers, for example, you are doing exercise. Okay, how you can use IoT to perform your tracking. Okay, parking sensors, connect health. Okay, and then also smart city. Okay, so these are application of IoT currently. Okay, I think later we will also talk about this one in the end of the talk. Okay, about IoT application using 5G. All right. So now I think we go to 5G first. Okay, 5G. Okay. Anyone know what is 5G? Any idea what is 5G? What is G? What is G? Okay, sorry. What is G? Okay. Any idea? Generation. Okay. Here G is generation. All right. So Yeah, so yeah, correct. From Jiang Xiaohui. Okay, it's actually already written here. Okay, G here is generation. So technically, okay, so we can say that for G itself is normally used for the wireless mobile phone technology. Okay, so this 5G is actually the fifth generation of wireless mobile phone technology. Okay, so why suddenly we are now already in 5G? Okay, have you experienced in a 1G system? Any one of you? Any experience in 1G system? Or maybe you haven't born yet. you, you still don't know where. All right. So yeah. So do you have any dial up? Okay. Dial up. Okay. So yeah, I'll show you this one first. All right. So see. Okay, this one. Okay. Okay, can you identify what is your first phone? You have it in these pictures. You have it? Any one of you? Sorry. Let me check this. Okay, Nokia 3310. Okay, so yeah, Nokia 3310. That one is I think almost everyone has it. Okay, for that one is in the era of 2G systems. Okay, so myself also I have my own mobile phone in the 2G system. For 1G, okay, so sorry. So this one is the picture is a 1G system. Okay, where still the size of the phone is quite big. Okay, in the but this one is in the era of 1G system. This is the most famous one. Okay, don't say Tumblr, you know, but actually, okay, before this Motorola, the brand of design is Motorola. Okay, before this phones, okay, there are some phones, okay, that the weight is 4.7 kg. Can you imagine a mobile phone, but the weight is 4.7 kg? Okay, you carry all those those phones, okay, 4.1. Okay, you put in your bag also quite heavy. Okay, but thanks to the development of the chip technology, the transistor technology, so that now we can put our phone in our pocket, right? So it's come with a 2G system. Okay, this one is 2G system. The some phone in 2G. Okay, this one is iPhone is for in 3G area. Okay, and then this one is some phone in 4G area. Okay, analog yes. Using, okay, so I'll go through what are basically 1G, 2G, 4G, 3G, okay, in the this evolution. Okay, so this shows the evolution of mobile communication. All right, so the bulky mobile phone, okay, in the 1G system is actually can only doing calling, or they only provide the voice service. Okay, so some more they use the analog communications. Okay, so all the circuit bank is using analog. Okay, so that's why they're quite big. And then the data speed, they don't have data yet. Okay, but the speed, okay, of this 1G system is quite how to say, quite slow. Okay, and then in the year of 1990, okay, we start with the 2G system. Okay, so starting from 2G, okay, all the communication is using digital communication. right? So the example of this 2G system is using GSM or CDMA. Okay. The speed is about you can see here is only 270 kilobit per second. All right. So what you can do is 2G system. Okay, what you can do is in 2G system, you can call and then SMS. Correct. But then in the end of era of 2G system, you may sometimes we call like 2.5 G system or 2.75 G system. That one is when the data communication is supported. Okay, when the data is supported, so you can browse internet with a very low speed there. Okay, and that one is using like what they call as a GPRS. All right, that one is considered as 2G system. And then in the year of 2000, okay, but if not mistaken, the real application of 3G system is around 2006 or 2007. All right. So in 3G system, what we can do is we can perform the image browsing. Okay, and then you can also perform the video call. Okay, but the video call in 3G era, okay, in 2000, say 2008 or 2009, it's not like our time now. Okay, we can do like video call using WhatsApp and so on. Okay, that era, okay, we have no kind of mobile application. Okay, there is no such thing that can support us. Okay, so even last time we do video calling, but the speed is quite low, 14.4 megabit per second. All right, and then move to 4G systems. 4G systems start at 2010, but I think is the real application is maybe 2011 or 2012. Okay, so here the speeds of the communication is, you know, tremendously increased. Okay, from 14.4 megabits second now become 100 megabit per second. Okay, and this is called as the LTE advanced. All right, what you can do in 4G, okay, you can perform like video calling. Okay, the quality of the video is high using HD video. All right, and since this 4G, right, I think this become our needs. Okay, it's like our water. Okay, it's like water and electricity for us. So the user, okay, the user is very demanding to the connection, the fast connection. Okay, and also this also can support for like video conferencing, okay, with fast connection. All right, so and then in 1G, 2G, 3G, and 4G, okay, they basically focus on the communication between people to people. Right. So but in 5G, okay, the aims for 5G is they also can connect, okay, device to device. Okay, so people to device, device to device. Okay, so everything can be connected. Okay, everything can be connected. Okay, so the 5G speed is up to 10 gigabit per second. Okay, latency is quite fast, about 1 millisecond. Okay, and then they also support very dense devices. Okay, so 1 million devices per kilometer square. So is so the density of the device is quite high, okay, for 5G. Okay, how it become like this, we'll go through later. Okay, so okay, so this one is the overall vision of 5G. Okay, so they are trying to give tremendous impact to the society, okay, by providing a flexible, adaptable service experience, okay, for the users, okay, and then in many scenarios, okay. So like you see here, okay, there are many scenarios for the application of 5G, okay. What they are trying is to achieve this vision, okay, information at your fingertips, everything available, and enable the internet of everything. Okay, so everything must be connected to the internet. Example, okay, example, okay. Even for our body, okay, maybe your specs, okay, they got some sensors, okay, that can give you better sights. Maybe your now is already so many smartwatch that can help you to perform some exercises, okay. And then maybe in your shoes, okay, there is some IoT devices that can help you to give you a data, what is your steps and so on. Okay, so this one is for people, okay, for the wearable devices, okay. But talking about smart home, okay, talking about smart home, I think you don't need later, okay, you just sitting and then everything is available for you, okay. You want to drink coffee, okay, you just say something, or you just push some button, and then the coffee is already available for you, okay. You want to wash your clothes, okay, you can adjust the schedule, and then the washing machine can just do the works by itself, and so on, okay. So this is some application, okay, that can be can be supported by 5G, right? And then okay, to achieve this one, okay, to achieve this very smart things, okay, so 5G has this key performance, okay. The first one is the latency, okay. The latency is how fast the data should be transmitted, okay. So it's the latency is about 1 milliseconds, okay, quite fast. And then compared to LTE, LTE is the 4G system, okay, it's about 30 or 50 times, okay. And then the throughput, okay, the speeds, okay, 10 gigabit per second, okay, per connection. So it's actually 100 times, okay, compared to LTE. And then the connection, okay, density of the devices or the users is 1 million connection per kilometer square, okay. Because again, for 5G, they not only aim for people-to-people connection, but they want to connect people with devices, okay, and then also connect the device to device. All right, okay, so this one is 100 times bigger than LTE. And then the architecture, okay, the architecture, they more use this slicing. What is slicing? Actually they are using kind of virtual system, okay. Later I will talk a bit about that one, okay. I will not go through to very technical things here, right? So how to achieve this one, okay? How to achieve this performance? So they use the millimeter waves, okay. Millimeter waves is, they use the quite high frequency, okay, 30 and 300 gigahertz. So using high frequency, of course, it can carry a lot of data. Okay, so that's why it can increase the speeds. Okay, and then they also place the small cell. Okay, this can be 250 meters. Okay, for every 250 meters, there will be one base station there or one cell. Okay, so this one is to support the connection, the number of connection. Okay, and then they are using the massive MIMO. Okay, so in one device, there will be many antennas. Okay, so that it can connect it to the base stations. Okay, and then also perform full duplex. Full duplex means that receiving and transmitting data will be in the same frequency. Okay, in the same time, and then also support machine-to-machine communication or device-to-device communication. And then for network slicing is that they will use the multiple virtual networks, okay, on top of the shared network. So like instead of for one infrastructure, okay, for example, this one is for voice, okay, and then the next one is for image and so on. Okay, instead of they have a different system, they only have one network. Okay, so that but they use the virtual networks. Okay, so every single virtual networks will actually perform its own task. Okay, so this one will actually how to say make the efficiency of the bandwidth. Okay, because you don't need to use so many frequency channels. Okay, to perform the communication. All right. So and there are three. Okay, there are three typical service application for 5G. The first one is called the EMBB. Okay, enhanced mobile broadband. Okay, and the data rate is about 8 gigabyte. Okay, movie downloaded in 3 seconds. So normally what you can be found for this EMBB is the virtual reality, okay, live sports, and then also you can enjoy the high division of video streaming. All right, and then the next one is URLLC, ultra reliable low latency communication. Okay, and so it's actually performing a very fast communication. Okay, for example, the application is for the autonomous driving. Okay, so talking about autonomous driving, you just imagine the car, right? Okay, if we drive the car, okay, we have to respond. The incident is quite fast. Okay, for example, how to turn left, how to turn right, and so on. Okay, how to stop. Okay, it must be very quick. Okay, response. Okay, so that's why it can minimize the accident. Okay, and also this kind of drone also application. Okay, it's also must be quick. Okay, and then also smart manufacturing. Okay, smart manufacturing. They plan to for example, one machine can communicate with another machine. Okay, so if they can talk each other. Okay, so what action in for example in machine A, okay, then when they want to transfer to machine B, okay, these two machine must respond with each other very fast one. Okay, otherwise there will be a delay. Okay, so that will actually destroy the manufacturing process. Okay, the last one is massive machine types communication. Okay, so yeah, this one is for the how to say it's kind of smart city. Okay, there are so many devices and sensors in the city, so that's they can connect it with each other. Okay, without any problem. Okay, so this one is the three typical service of 5G. Okay, and then for example, here is for industry. Okay, so they can be used also in the smart grid. Okay, so can use this for monitoring and controlling the smart grid, and if there is a fault, okay, they can recover quite fast. Okay, last one is next one is for is can be used for the agriculture monitoring or forestry monitoring. Okay, and then next one is smart healthcare. Okay, so remote surgery is possible. Okay, the doctor is there, and then the patient is somewhere else. Okay, then doctor just let's say is just give the command, maybe the machine will do it. Okay, and then smart manufacturing. Okay, smart manufacturing can normally in the manufacturer they use the robot, so it can use to control the robots and so on. Okay, so this is some applications. Okay, and then I think will be the last slides here. Okay, in here. So okay, talking about big data, IoT and 5G. Okay, so 5G is the key of the technology itself, because network is actually the heart of this IoT and big data. Okay, so but here I say AI because AI is something related to big data, but is different things. But actually the three technology that can drive us to the digitalization is this 5G, IoT, and AI. Okay, what this can be benefit to us is that, okay, in the global, okay, talking about global economy, it can how to say, reach 23 trillion US dollar, okay, in the year of 2025. Okay, and then the annual growth rate, okay, of the digital economy, okay, is can reach for 18.9%. This one is actually from Huawei. Okay, this prediction is from Huawei, and then the GDP, okay, can reach to 32.9%. Okay, and then the return of investment, okay, in terms of business is 6.7 times better, okay, compared to this time without these three technologies. Okay, so why this technology can benefit like in terms of economy is like this one. Okay, because just imagine, okay, for example, just imagine the smart manufacturing. Okay, smart manufacturing using robots, right? Using robot, and then this robot is controlled by this 5G, IoT, and AI. Okay, so if, and of course there will be big data there. Okay, if the robot is controlled very fast, okay, the response is quick. Okay, they can do things very fast, so it can actually increase the productivity, okay, in the manufacturing. Okay, and then they can also reduce the failure, okay, in the production. Okay, so that's the benefits is getting bigger. Okay, and then talking about what else? Okay, food delivery. Okay, now I think some countries they already perform food delivery using drone. Okay, if using we order the food using maybe here Food Panda. Okay, sometimes it depends on the driver. It depends on the driver how fast they will reach us. But then if they use drone, okay, it can be controlled, okay, the speed and so on. Okay, somewhere there is no traffic in the air there, so that we can get the food quite fast. So time is money, right? Okay, so we can save our time, we can save our money also, right? So then this is how when all digital era will comes to us. Okay, I think we are going to that particular era, but still on the way. All right. Okay, so as a conclusion, okay, so I will conclude that IoT application that generate small data with large volume and fast velocity will need 3G. Okay, with the characteristic of high data rate and low latency to transmit the data. Okay, and then 5G will serve as a better gateway and transport network for IoT applications so that IoT data can be delivered more efficiently and economically. Okay. And in addition, IoT will become one of the major sources of big data by producing large volume, fast velocity, and many varieties of data that require big data analytics to obtain valuable information. Okay, so actually this figure is the relation between the current technology, not only 5G, not only IoT, not only big data, but also AI, cloud computing, and so on. Okay, so these three technology must integrate with another technology. All right, so I think this is the end of our talk. So thank you very much for your attention. So I open for Q&A session. All right. Oh, yes.
Thank you, Dr. Arno, for the interesting and insightful talk. So now I will open the floor to the audience for Q&A. So yeah, you may raise your hands to enable your mic to ask your questions, or you may write your questions on the chat. Since our time is limited, and we are already almost reaching the time. So perhaps I will allow one or two questions. I see in the chat now we have Tang John Sun. You have a question. Yeah, perhaps you can, if you want to ask, you can enable your mic and ask directly to Dr. Arno.
How can the Internet of Things will be affecting the smartwatch or smart glasses? Does it related to it?
Okay, so basically in your smartwatch, okay, you have a sensor. For example, you are talking about what to say, the heartbeat sensor. Okay, maybe some other sensor, maybe oximeter sensor and so on. Okay, that is embedded in your smartwatch. All right, so the basic idea of IoT is that the device or the sensor, okay, will generate data. Okay, so this smartwatch is actually the one application of IoT. Okay, that this your data, for example, your heartbeat, okay, can be sent through the cloud, okay, or maybe the data center, okay, and then in the data center, that your heartbeat can be processed. Oh, okay, for example, when you run, what is your heartbeat? When you walk, what is your heartbeat? So using this data, okay, maybe it can be used to analyze whether your heart condition is good or not, and so on. Right? Can you get the idea? Tang Johnson. Do I answer your question?
I can.
Yes. Okay.
If
So whether
let's say So, excuse me. So if let's say I am having, if I want to run, right, does it just check my blood pulse if I'm wearing the smartwatch?
Okay, so I mean, like, because like your smartwatch is you do yourself, right? Okay, but if you want to get like a better analysis, okay, better analysis, you give this, for example, to the doctor, or maybe to like to the expert, okay, to the expert. Okay, your smartwatch is just generate and collect the data. Okay, the processing of the data, the analytic is of course done by the expert. Okay.
All right. So thank you for that question. Perhaps we have time for one last question. This is from anonymous user. How to capture a data from IoT device? Is there any tools?
Depends on the application. Okay, so depend on the sensor. Basically, okay, basic of IoT is wireless sensor network. So depends on the sensor that you attach. Okay, for example, okay, I use this for the healthcare application. Okay, for diabetes. Okay, some install the what they call the urine, not urine, the what it diabetes is the level of the what they call the glucose, the glucose, the glucose level, okay, in your blood. Okay, so of course here, okay, you need the sensor that can be able to detect the glucose level. Okay, so of course practically yeah, there are so many ways to get the data, okay, depending on the sensor that you use. Okay, temperature sensor, of course the sensor will capture the temperature, okay, and then in the sensor itself, okay, it will have the small processing unit, okay, how to this temperature or the glucose data will be sent through the network. So this is the way how to capture. Okay, so depends on the sensor. Okay, sensor is the one which sends, okay, the data. Okay, actually I got one question, Dr. Gan, from SIM.
Yep, correct.
Okay, so from the academic point of view, okay, I think this COVID-19 pandemic really show us, okay, what is the benefit of this technology. Okay, so for example, like during these 2 years, right, the development of teleconference technology. Okay, so before maybe Zoom is there. Okay, we have Skype and everything, but in terms of application, okay, we don't have such a feature like this these days. We can share screen and so on. We can add those so many features there. Okay, and then also with the high speeds, okay, if we have this kind of platform or application for video conferencing, but if not supported with the high speed connection, also useless. Okay, also useless. Okay, so this is the benefit that, okay, maybe there will be later many courses will be offered, okay, is using online. Okay, so that's student no need to travel and so on. Okay, so that's the benefits for us, right? So
All right. Thank you very much to all the participants and for your support, as well as for posing the questions to our speaker today. Okay, so that is all for today's webinar. I would like to thank the audience for your cooperation and support in making this webinar engaging and beneficial for all of us. So for those who are interested to know more about the undergraduate degree programs offered by the Faculty of Information and Communication Technology, so you may visit the faculty website at fict.utah.edu.my for more information. So till we meet again, have a productive day ahead and stay safe. Thank you very much.
Thank you very much. Thank you, everyone. Bye-bye.